Welcome to qnawire.
So now we'll work on problem 102 from chapter 13. In this problem, we want to know the amount of mass of ethylene glycol that we would have to dissolve in 14.5 kilograms of water to keep it from freezing at -12 Fahrenheit, assuming ideal behavior. So the first thing we need to do is go from Fahrenheit to Celsius. So we have -12 Fahrenheit, so we do -12, we subtract 32, and then we multiply by 5/9. And we get a value of -24.4 degrees Celsius. So we want to keep water from freezing at this temperature value. So we know that water typically freezes at 0. So dt is 0 minus 24.4. So it's just simply 24.4 negative. And so this here is equal to the freezing point depression constant, as well as molality and I, which will be 1 for this problem. So M we can calculate. So we're actually seeking to calculate M. So we know Kf, we know the dt, we need to calculate M. So Kf is equal to, let's go ahead and redraw this here. Kf is equal to 1.86. And we can get rid of I since it's not going to play a factor because it's only 1. So we solve for M by dividing both sides by -1.86. And that gives us a value of 13.118 moles per kilogram. If we multiply this by 14.5 kilograms, which is the mass of water that we want to keep from freezing, we'll know the amount of moles that we need. So we need 190.211 moles of ethylene glycol to keep this water from freezing. So the last thing we need to do is to convert this to a mass. 190.211 moles times the molar mass of ethylene glycol, which is 62.08 grams per mole. And that gives a value of 11,808 grams, or 11.81 kilograms of ethylene glycol.